Hmm. All right. Let's see who's here. All right. It looks like we're pretty much all here. Very nice. All right. So what shall we do today? All right. So here's what we're going to do. I do have a video here that I'd like us to see today. And let me just go get it. Okay. All right. So this is a interesting discussion about supply and demand, which we've been working on the last couple of days. And so there's some videos I find on YouTube that are actually quite useful. You know that YouTube has a lot of pretty awful stuff, but there's also a lot of excellent content as well. And so whenever I find something that ties together what we've been doing, I like to show it. So now the only problem is, and I've run into this before, if I just show it on my screen, there's a very real chance that you won't be able to hear it. Sound might not be very helpful. So what I had started doing in the past was I would put the link into the chat room, and then we'd all watch it on our individual screens. And then what it turns out that by if I show this in the recording, there's at least a chance of running into copyright problems. So what I will do is I will send you the link, and you'll want to watch it on your home screens. But and I'll watch it here too. But the recording will have to be paused while the video is being played, so that if you do watch the recording later on, you'll notice that the video is missing, but you'll have the link anyway. So if you do want to watch it again, that's fine, but it won't actually be part of the video, because you never know what's going to happen. You got to watch out with the. I mean, the videos are technically copyrighted, and so for us to show it in a recording, if you want to be crazy technical about it, I guess we're not supposed to do that. So the first thing I'll do is send you the link, then I'll pause the recording, and then we'll all watch it on our own screens. And then when we get back, we'll go over what was discussed in the video. All right, hold on one second. Here it comes. It's going to come to you in the chat room. You should have no trouble finding it. And once you see it, just click on the link and the video will start. And then we'll watch it. I've forgotten how long it is. It's only about 5 or 6 minutes at the most, but I think it covers a lot of important details that we've been doing and helps provide more background for this very, very important topic. All right, so why don't you all click it on and we'll get started.
So glad you were able to thoroughly explain that to me. Unfortunately, I'm really fucking stupid and you're gonna have to. Wait again, I'm so sorry. So glad you were able to thoroughly explain that to me. Unfortunately, I'm really fucking stupid and you're gonna have to explain it yet again. I'm so sorry. So glad you were able to thoroughly explain that to me. Unfortunately, I'm really fucking stupid and you're gonna have to explain it yet again. I'm so sorry. So glad you were able to thoroughly explain that to me. Unfortunately, I'm really fucking stupid and you're gonna have to explain it yet again. I'm so sorry. So glad you were able to thoroughly explain that to me.
To all your friends, you understand supply and demand. It's a big day for you. It's a big day.
So markets and supply and demand fact, now there's a huge shortage and thousands of people die each year waiting for transplants. Should there be a competitive market for human kidneys? Say, sure, why not? If a donor wants $15,000,
All right, is everyone pretty much done? All right. So yeah, it's like a different perspective. Yeah, I mean, it's kind of interesting, these strawberries, but I mean, they explain very well how the price system does ensure that consumers will get the best products that they can get for their money, as well as producers being able to produce the most profitable products. So prices represent an incredibly important type of information in the marketplace. So in a free market, resources will be as allocated as efficiently as possible. But anyway, so why don't we move on now to chapter 5? And let me get this back on. So in 4, we were looking at supply and demand. In chapter 5, we're looking at sort of an extension of supply and demand. What we're trying to think about here is the idea that even though people will buy less of a product when the price goes up, and they'll buy more of a product when the price goes down, the amount by which they change their spending habits isn't the same for every product in the marketplace. So, for example, as I think I mentioned here, we started to look at this last time, and what we're interested in here is this idea of how much. In other words, we know that if the price rises, the quantity demand will fall, and if the price falls, the quantity demand will rise. The question is how much, okay? And this is the part that can be very different from one product to the next. For example, I think I used Starbucks as one of these examples. Yes, here it is. So for a computer, a 10% increase in price is $200, which could be enough for a lot of people to change their minds and not buy this computer or else buy a cheaper one. So 10% isn't a huge amount, but because that translates into $200, that could be enough to cause a lot of people to switch to something else. Whereas if the price of a Starbucks that started out at $2 went up by 10%, that's only 20 cents. And you might not even realize that the price is going up. So the vast majority of people will just continue to buy the coffee, even though the price went up to 2.20. So yes, technically, the law of demand is applying in both cases, but the difference is that in this first case, the change could be very significant. In fact, let's see if we can draw a couple of demand curves to see how this works. Hold on one second. So imagine this is the demand for computers. Here's the price and here's the quantity. So what we have to imagine is that here's the demand curve. It's fairly flat because what happens is if the price is, let's say, 2,000, we sell, I don't know, 10,000 computers every month. If the price goes up to, let's say, 2,200, you can see that there's going to be a very substantial reduction in our sales, let's say to 8,000. So the price went up 10%, but the quantity demanded went down by 20% because people are very sensitive to price changes in this market because they represent a significant amount of money. 10% is $200. So the computer company is probably going to regret this decision because while the price went up 10% and each computer brings in more revenues, at the same time, they've lost 20% of their business. And so this is probably not the best move of all time because on balance, their total revenues will be lower now. Right. In fact, we can figure it out ourselves. The total revenue of point A, I'll call it TRA, is 10,000 times, let me make some more space here. The total revenue of point A is 10,000 times 2,000. Okay, so they sold 10,000 computers at a price of 2,000 each, and that translates into $20 million. Wow, it's a lot of money. But when they raise the price like that, you see what happened here. Where they're only selling 8,000 computers at a price of 2,200, and so their total revenue now is going to be 17,600,000. Oh boy, somebody's in trouble. Whoever made the decision to raise this price by 10% is in trouble with this company, I'm guessing, because their total revenues are off by quite a bit, as a matter of fact. That's not a trivial amount of money that they're losing, and it's all because they decided to raise the price by 10%. Now, on the other hand, in the Starbucks case, they're raising the price from $2 to $2.20 because it is also 10%. And so now here, you're going to get a very different scenario because let's say that they're currently charging, and by the way, if you notice, the demand curve here is very, very steep. At a price of $2, let's say they're selling 1 million cups of coffee a day. At a price of $2.20, that goes down to, let's say, 9,900,000. So let's take a look. This will be point A, and this will be point B. At point A, the total revenue is 1 million cups at $2 each, which is clearly $2 million. And then at B, we have 9,900,000. Sorry, what did I do? No, this is wrong. My fault. This is not 9.9 million. It's 990,000. Sorry about that. I was going to say something's not right. All right. And so, yes, they're only selling 990,000 cups, but they're also collecting $2.20 each. If you multiply out those numbers, you'll see that now our revenues are $2,178,000. So in this case, the decision to raise the price was actually a good move because yes, they lost some of their customers, but the extra money coming in is more than enough to compensate for that. So this is really the bottom line right here, the total revenues. That's what matters to the company. And so their job is to always find the right price to charge for a product at which they maximize their profits. That's just the bottom line. And so a lot of research is dedicated towards finding out how sensitive people are to changes in prices, and that's going to help determine what the best possible price will be. So this is Starbucks coffee. So it's a very different market than the demand up here for computers, where people are very sensitive to price changes. I'll make a note of that down here, very sensitive. And down here, not very sensitive. I mean, can you imagine walking into a Starbucks, standing in line, and you get to the cash register, and they say, "Oh, by the way, we raised the price 20 cents today." I can hardly imagine anybody saying, "Oh, well, then I don't want it. I'm going to walk out of here." It's just not worth it for 20 cents. So anyway, so what we're going to do with elasticity is try to come up with a single number that quantifies how sensitive consumers are to changes in price for a particular good. And it can range from very little to very much and everything in between. And we're also going to try to understand what is it that causes these differences to exist in the first place. It's not just the price, by the way. There are other factors that can influence our sensitivity to price changes. So we're going to look at those as well. So first, we want to formally introduce the three basic types of elasticity. The one we've just been discussing is formally known as the price elasticity of demand. And by the way, the word elasticity, as it's being used here, is really just another word for sensitivity. If that helps you understand this concept better, elasticity is just another word for sensitivity. So here we're looking at how much people will change their spending habits based on the price of a good. In the second case, though, we're thinking not so much of the price of the good, but our incomes. As our incomes change, our buying patterns will also change. And so we're trying to capture how sensitive our demand is for good based on our incomes. Now, the cross elasticity refers to the relationship between two different products, which we'll analyze when we get to that point. But given that we have limited incomes, if the price of a good changes, it will have an impact on the demand for other goods that are related to each other somehow. So we'll see that when we get to that point. But let's just focus our attention now on price elasticity of demand, because this is definitely the most important one. Okay. So first of all, now this is the formula that we're going to use. Now, this is a scary looking formula. This is really just shorthand notation. The delta, this is the Greek letter delta. You saw it plenty of times in high school in math. Delta just means change. And when I attach that percentage sign to it, it becomes percentage change. Okay, so delta itself is sometimes known as absolute change. And percentage delta is percentage change. So I'm going to show you the difference between the two cases. All right, first let me give you a minute to catch up. Then I'm going to show you mathematically what is the difference between these two. Okay. And of course, you see that we do the same thing in the denominator to the price. This Q is the quantity demanded. And the P is the price. Okay, so notice you can see what we're effectively trying to capture here is this ratio of the sensitivity of the quantity demanded to any particular change in the price. All right, so let's take a look at what these percentage changes actually represent. Imagine the following scenario. Let's say that you are buying a stock. All right, so in other words, this doesn't have to be goods and services. Let's just say that you buy a stock. I guess I can do it here. All right. Suppose that an investor buys a stock for $100. At the end of the year, or 1 year later, the price is 105. Okay, now, using the notation we'll be using in this chapter, the stock price, we'll call it P0 for the initial price. Which is 100, and then 1 year later will be P1. That would be the new price, let's say, a year later. So the absolute change in P is simply P1 minus P0. So the price is going up by $5. The percentage change means that what you're doing is taking one more step. You're converting this to a percentage by dividing out by the original price. So instead of a dollar amount, it suddenly becomes a percentage. Okay. Now, many applications, the percentage change is the more important number, but sometimes the absolute change is what we're after. So this is a brief review of absolute change versus percentage change. This is important. We need to understand this before we go on any further. All right, so there's an absolute percentage, there's an absolute change, and there's a percentage change. And it's important to understand the difference. So in this chapter, we will be focusing exclusively on percentage changes. All right. So with that being said, we can now go ahead and use this price elasticity formula. So now it turns out that there is one minor change we have to make to this formula, and I'll show you why in a minute. But in principle, this is how you calculate percentage changes. All right. All right, so as soon as we're ready, I don't want to rush through this. We'll go on to the next slide. All right, and then this is just here to remind you that delta represents the change. Oh, here I've got Q2 and Q1. You know what? I'll tell you what. In some books, they use 0 and 1. Some books, it's 1 and 2. It means the same thing. All right, I just want to point that out. It looks like we're going to be using 1s and 2s here, which is fine. Just be aware that, oh, here we go. The slides will take care of this. If you're looking at the quantity demanded, the absolute change is Q2 minus Q1. As long as this number is larger than this number, it doesn't matter. You could have Q3 minus Q2. The difference is here. Okay, this is what we need to know. So this is the absolute difference. Because remember, these subscripts represent time. These are, let's say this is 2 years in the future and 3 years in the future. So the first one will be, in this case, 1. The second one will be 2. And then when we write it out as a percentage change, we're going to divide by the initial value, whatever it was. So in this case, I'll write that up here. That means in this case, we would write this as Q2 minus Q1 over Q1. These are always the same number. Okay. Some books, in order to make it even more general, let me just show you another way this could be expressed. You could write it like this. QT plus 1 minus QT over QT. The T is time. So whatever T is, T plus 1 is a year or a period later. So this is the most general expression of percentage changes. As long as it's clear that these are time subscripts, it doesn't matter if this is 0 and 1 or 1 and 2, whatever. These are 1 year apart, and this is the initial value. All right, now the same thing is, we've already seen this. The absolute change or difference in P, it looks like we're going to be using 1s and 2s in this book. And that's going to be very similar because you're going to just have the difference. Okay, and again, just remember, this is the latest or newest price. And this is the previous price. And then the percentage difference between the two is going to be obtained by taking that same expression and simply dividing by the initial price. Now, for the elasticity, we're actually going to take the ratio of these two ideas. The percentage change in quantity is always in the numerator, and the percentage change in price is always in the denominator, because we're trying to capture how sensitive the quantity demanded is to changes in price. Okay, so in other words, when we finally bring these together, let's see, let me throw this in here. So the elasticity formula, which I showed you up here, is formally going to be written then in the following way. So the price elasticity of demand, which is expressed very simply as percentage delta Q over percentage delta P, is equal to Q2 minus Q1 over Q1, all divided by P2 minus P1 over P1. Now that looks like a scary formula, doesn't it? It is to a certain degree. Now, I do want to show you something algebraically that might be a little bit more convenient for you. It turns out this is equivalent to Q2 minus Q1 over Q1 times the inverse of this ratio, P1, P2 minus P1. Algebraically, as you might recall, if you have, let's say, 1/2 divided by 3/4, it's the same thing as 1/2 times 4/3. That's where this is coming from. I don't know about you, but I like this a little. I just find that this is easier to deal with. I think over here, you're more likely to run into mistakes. So this is the same as what's on the left. This formula up here on the top is actually telling us to do this. And that's the actual definition of price elasticity of demand. There's just one problem. There's always problems, aren't there? Yes, what am I referring to? I'll show you based on the demand curve. All right, we all caught up? All right, there's one real serious problem with this formula, which means it needs to be adjusted. Here's what I'm referring to. Let's make up an example. I hope I can keep it all on one slide. Let's say that we have a demand curve. And let's say that the price is 10, we sell 100 units. When the price is 5, we sell 150 units. So what I would like to do is imagine a scenario where the seller of this good cuts the price from A to B, thinking that this will increase his revenues. So why don't we figure out the price elasticity of demand using our formula, percentage delta Q over P, as you remember, is Q2 minus Q1 over Q1. And then let's use this version. Now, because we started at A, this tells me that P1 is 10 and Q1 is 100. Therefore, P2, the new price, is 5, and Q2 is 150. So if I plug in these numbers, I'm going to get 150 minus 100 over 100 times 10 over 5 minus 10. All right, let me make sure I did that right. 150 minus 100 over 100. Yeah, that's right. All right, so what we're going to get in this ratio, I have 50 over 100. Here I have 10 over negative 5. And it turns out to be negative 1. Now, here's the challenge. And this is where the problem comes in. By the way, I want to point out here that the price elasticity of demand will always give you a negative number, because when the price goes up, the quantity demanded goes down, and vice versa. Here's what we want to do now. Let's consider the opposite situation. What if we started at B and moved back up to A? In other words, imagine initially the price was 5, and we decided to raise the price. So now, in scenario number 2, which I'll do with another color, just to remind you, this is a different situation. I don't know, let's try purple. Now all of a sudden, P1 is 5, and Q1 is 100. No, sorry, 150. P2 is the 10, and Q2 is the 100. So now I'm going to plug these numbers into the same formula. I'm going to have 100 minus 50, 150, over 150. Over here, I'm going to have 5 over 10 minus 5. So I'm going to have minus 50 over 150 times 5 over 5. And guess what? Look what happened. It's different. So here's the rub against the formula that we're using here. The size of this effect depends on which direction we're moving, down or up the demand curve. Now, this is something that is not terribly useful, but there's a way of working around this, which we will be using in this chapter. In other words, there's basically a compromise position we can take, which guarantees that this will never be a problem. Unfortunately, this makes the formulas a little bit messier, but it does make sure that we don't ever have to worry about this issue here where the elasticity depends on which direction we're going in. So what could this new approach possibly be? Let's find out. All right, are you ready? Don't want to rush this. Okay. And just switch this back to black. What we're going to basically do is this. Just sort of a, to make sure this doesn't constantly happen, we're going to create a new formula in which we incorporate averages. So in effect, what we're going to do is now we're going to actually calculate the average elasticity between these 2 points, knowing that it won't be perfectly accurate, but at least knowing that it'll be the same if we go down the curve or up the curve. Okay, so how does that work? Here we go. So this is what we're going to come up with. In other words, you notice that the Q here has been replaced by the average Q, which simply means take the 2, add them up, and divide by 2. And down here, P, just plain old P, has been replaced with the average. And it'll turn out that will make sure that no matter where we are in the demand curve, we'll get the same results whether we move up or down the curve. It is a little messier, but it will do the job. All right, so yeah, well, why don't we do an example? Now, what I'm going to do in the next slide, I'm going to write out what this looks like now when we bring it together. Okay. So let's insert a new slide. And so basically now your elasticity equals and now I'm going to write it in a more convenient way, which, or at least I think it's more convenient. All right, so notice I use the same trick that I did before. Remember, 1/2 times 3/4 is the same as 1/2 times 4/3. I just think it's easier this way. Look at all these ratios. Look how easy that would be to mess it up. I do think this is a better way to go. All right, wow. Man, all these calculations. So far, we've just done theory. Now we're doing calculations. So hopefully you have a calculator in front of you. If not, I guess you all know that you can use your iPhone as a calculator. In fact, I'll show it to you right here. Let's get this thing out. If you take your iPhone, and now among the many, many apps that come with it, which means you can't delete them. Here we go. Look at this one. You all have it. Now, here's what you may not have known. If you hit that button, you'll get this very basic little calculator here, which you can do about 4 things: add, subtract, multiply, and divide. That's pretty much it. But if you turn it on its side, wait a minute, all of a sudden you've got this full high-powered scientific calculator at your fingertips. That's right. Did you know that? Ooh, I bet you didn't. I'm sure that when you're playing with your iPhone, the last app that you look at is the calculator. But that's okay. For this class, you need it. So if you don't have a physical calculator, this is good enough. In fact, it's plenty good. It's a very good calculator. You just have to get used to it. Every calculator is slightly different, especially with the parentheses. So what you should probably do is pick a calculator and get very good at it and just use that forever. All right, just pick one and stick with it. And it could be this one, unless you need something more specialized. Like in a statistics class, you probably should upgrade to something like the Texas Instruments 84 series. But here, this is plenty. All right, and since many of you are, I mean, in a micro class, I figure at least some of you are going to major in either some business application or economics, which means that sooner or later, you'll be using statistics or taking a statistics class, and then you'll need a more advanced calculator, but not here. This is fine. All right. In fact, oh, I just thought of that. That would be a great poll. More out of curiosity. Oh, I already asked about economics. Oh, I forgot. All right. Well, I'll tell you what. Let's change this slightly to the following. And you probably already know if this is true or false based on your scheduling. Do you have to take a statistics class? Okay, so regardless of your major, you probably, I mean, I imagine somebody's already sat down with you and talked to you about your course requirements, which they really should do with you on your freshman year. So it's just that this is just purely out of curiosity. Wow, so far it's right down the middle, 50-50. All right, well, okay. No, the only reason I'm asking is because you will continue in a statistics class. It's a very different kind of quantitative methods. It's very quantitative, but a little bit different than what we're doing here. But if you do get to that point, you'll probably want to look around for a pretty serious calculator like the TI 83 or 84 series, or if you already have one, that's wonderful. Oh, one math, but not necessarily statistics. Oh, I get it. Okay, well, I like that idea. But I have to tell you quite honestly, if you're in a business discipline of any kind, um, try to grab a statistics class because I think it'll really, really help you more than anything else. Um, even if you have to sacrifice another elective to do it, it's that important. It really is, because everything you do in business is eventually related to statistics. Calculus is great too, but I think for business people, and especially economics majors, stats is really, really important. That's just my opinion. I don't want to, I don't want to tell you what to do, but that's my opinion. So let's go on to what we were doing. So let's see. Okay, where did we leave off? All right, so let's do this example. By the way, it looks a lot scarier than it is. Once you've done a few of these, you'll say, oh, it's so easy. So here we go. Here's our pizza demand schedule. And let's just say that we're going to start at $8, and then we decide to drop the price to $6. Okay, the pizzeria thinks that this will help increase their revenue. So that means that this is P1. Sorry, this is P2. This is Q1, and this is Q2. All right, we started here, and then we've decided to cut the price, and which means there's no real room here, but we're going from, let's say, here to here on the demand curve. In other words, we're putting it on sale. I mean, they're not going to call it a sale in a pizzeria, but let's say it's a promotion. This week, the price is only $6. Come on in and join us. We're only having $6 pizzas all week long, something like that. Or else, now, according to what I'm seeing here in the example, this was triggered by savings in the cost of cheese. So the pizzerias have decided, you know what? All of a sudden, our costs of production have fallen. Why don't we take advantage of it by putting the pizza on sale and see if we can get more customers in the door? Now, the question, though, is from their perspective, how much will people react to this? In other words, it's possible that with a lower price that people will buy a lot more pizza. It's also possible that they'll hardly even notice it. They won't change their buying patterns at all. It depends on the demand for this product. If people find it to be like, if everyone loves pizza, and the minute the price goes down, they buy a lot more, that's one thing. It may also be that people have habits, and people who don't normally eat pizza will not be attracted by this. But we're going to find out by doing the numbers. So what we need to do is gather up all this data. And, like up here in the upper left-hand corner, you can see all the information is nicely organized. Now, because this formula is such a mess, it might make sense to do it in stages. In other words, you see what's happening here. We're rewriting it as delta Q over Q av for average, delta P, P av, or alternatively, now the delta Q is the absolute change. The Q average, you add the two together and divide by 2. So by doing these individually, rather than trying to plug it all into one gigantic formula, you're less likely to make mistakes, in my opinion. And look how easy this is. Here you're just calculating the change in the Q's. Make sure it's Q2 minus Q1, by the way. The average, you're just adding them together and dividing by 2. That's not a problem. For P, we do the exact same thing. And you can see the quantity went up, one, when the price went down by $2. The average quantity between those 2 points is 6.5 million. The average price is 7. So if I plug these in up here, I've got 1 over 6.5 times 7 over -2. Now I can rewrite that as 7 over -13. And then using my calculator, that's approximately -0.538. So I think you'll agree that by doing it in 4 stages like this, you really greatly reduce the risk of making mistakes. Okay, so that's how it's done. Now, the question is, what does this number mean? What is it telling us? That's a very good question. Okay, so let me just give you time to finish this. So first, again, we noticed that the price elasticity of demand is always negative because if Q goes up, P has to go down and vice versa. One of them has to go in the opposite direction of the other because the demand curve is downward sloping. You'll never get a positive price elasticity of demand. But it turns out that it's really the magnitude of this number that's of interest. The sign, we understand that it's negative, so that's not really telling us anything. It's the magnitude that is of interest to us, and we'll see why in a second. All right, so you can see that I did the same thing here and got that -0.538. And so now here's an important detail. In economics, since we understand that that number is negative, what we often do is just drop the negative sign. So if you read in a book that the price elasticity of demand for a product is, let's say, 1.2, it's understood that that's the absolute value, that they've actually done this. So in other words, it's understood that the sign is negative, so we usually ignore it, and we would typically express this as 0.538 rather than -0.538, because negatives confuse people, and so therefore, whenever possible, we try to avoid them. Okay. It's kind of like, remember when you were in high school chemistry and you're learning about pH, the pH of a base is anything from 7 up to, I think, 14, and an acid is like from 1 to 7 or 6. Anyway, but these numbers are actually negative. They just drop them to make it less confusing. So it's the same thing here. We just ignore the negative sign and we focus our attention on the size of this or magnitude of this number, because this gives us a lot of useful information. Now, how do we interpret this? Basically, what it's saying is that if we cut the price of the pizza by 1%, people will buy 0.538% more pizza. If we raise the price by 1%, the quantity demanded will drop by 0.538%. That's how we interpret it. All right, so this is what it actually is telling us. Now, that raises an interesting question. Should we cut the price or not? That's a separate thing we have to look at next. But here, what matters is that with this number, it tells me what happens to the quantity demanded of pizza due to a 1% change in price. This is the interpretation. Interpretation. This is what it means. Now, it turns out that we can actually classify the price elasticity of demand into three basic categories, depending obviously on its magnitude, not the sign, the magnitude. Here's how it works. Now, again, with the understanding that we're dropping the negative, there's three possibilities. Now, the demand can't go below zero, by the way. If we're ignoring the sign, then the demand price elasticity cannot fall below zero. So any number less than one, which is the one we just experienced, by the way, we say that the demand is inelastic. If it is exactly one, which is very rare, we say that the demand is unit elastic because unit means one. And anything above one, we say that the demand is elastic. Now, you might recall I did say that elastic is the same as sensitive. So if the demand is inelastic, it means that people are not terribly sensitive to price changes. Whereas an elastic is the opposite. If the demand is elastic, people are very sensitive to price changes. So if you recall, we had an example earlier on with computers and Starbucks. So let me just throw in a new slide here. And we're going to remind ourselves in fact, you know what maybe we should do? Why don't we go grab that example and calculate the elasticities? I like that. So for the computer, let's do that just to get some practice. It'll illustrate a very important point. For the computer example, okay, if we recall, we started out with a price of 2,000 and people bought 10,000 computers. When the price went up to 2,200, they only bought 8,000 computers. So the price elasticity of demand in that case, using this average approach, remember delta Q over Q average divided by delta P over P average, or delta Q over Q average times P average over delta P. Let's do what we did before. Let's do these one step at a time. Delta Q is 8,000 minus 10,000, which is a drop of 2,000. Q average is, add them up and divide by 2. $9,000. For the prices, with 2,200 minus 2,000, which is 200. And then for the average, we have 2,200 plus 2,000 over 2, which is 2,100. So I'm going to try to squeeze these into this formula up here. There's very little space, but I've got negative 2,000 over 9,000 times 2,100. Whoops. Over 200. And let's see what that turns out to be. It's negative 2.33. Okay, so what does that mean? Double checking. Yes, negative 2.33. Well, based on that chart we had a minute ago, this means that the demand for this product is elastic. And that means people are very sensitive to changes in price in this market, which is what we would have expected, because like I said, even a small percentage change translates into a large dollar change. So the demand, let me see if I can put this in here. Excellent. Now for the Starbucks, the price went from 2 to 220. The quantity went from 1 million, let's go double check this, to 990,000 if I recall correctly. Yes. Beautiful. All right, let's do that one next. For the Starbucks example, we have the initial price was 2. The quantity was 1 million. No, sorry, it was 1 million. And the price jumped up to 220. The quantity fell to 990,000. So once again, we'll use our formula. So we'll ultimately use this version of it. Now, let's do these one at a time. Q2, delta Q is Q2. Then we had QAV, this average of the two. Man, all those zeros, I'm running out of space. It's 995,000. Fit that one in just barely. Delta P is 220 minus 2, which is only 20 cents, of course. And then the average of the two prices P2 plus P1 over 2. $210. All right, so now I'm going to plug these in. Negative 10,000 over 995,000. The average price change. The average price was 210, and the change was 20 cents. All right, here we go. Negative 0.106, let's say. Okay, so based on the chart we had before, because this number is in absolute terms is well below 1, we say that the demand is inelastic. Because the absolute value of this term is well below 1. Okay, the other one was well above 1. Whoops, sorry. So you can see these are two extreme cases, of course. I mean, for the Starbucks, like I said, people barely noticed the price change. Whereas with the computers, people, a lot of people decided not to buy the computer after the price went up $200. So we can classify basically all goods in the economy based on this elasticity measure. And again, the values will range from as little as basically 0 all the way up to fairly large numbers, but it usually doesn't go much above 3 or 4, let's say. But the cutoff point between elastic and inelastic is 1. All right, wow, oh, that was a lot of calculations. So what comes next? Let me just quickly summarize this in a chart. So the price elasticity of demand, actually, let me make a chart. Oh no, we don't want that one. This is how you make tables in Excel, by the way, or PowerPoint. All right, so this is the product. Price elasticity of demand and classification. That sounds good. So for the computer, it was negative 2.33, although we really, let's call it 233. It's elastic for coffee. It was 0.106, and therefore the demand is inelastic. Okay, so remember the cutoff point between elastic and inelastic is 1 in absolute value terms. Now, that raises an interesting question. Did the computer company make a terrible mistake by raising their price? Let's find out. So let's see, let me go get the data again. The computers, we saw that the initial price, Q1, was 2,000. P1, no, sorry, what am I saying? The price was initially 2,000. And then at that price, they were selling 10,000 computers. When they raised the price to 2,200, the quantity went down to 8,000. So now what we're going to do is calculate the total revenue which is P1 times Q1, which is 2,000 times 10,000. Oh, I think we already did this, didn't we? Oh, that's right. Well, it's good to have it all summarized one more time. But now, see, here's the thing. We're going to tie these together, elasticity and revenues. And yeah, we did this earlier, but that's right. Let's do it one more time. 17,600, or 17,600,000. So what I want you to see here is this. Let's just double check this. The bottom line here is that with a high price elasticity of demand, raising the price reduces the quantity demanded more than it increases the price in percentage terms, that is. As a result, the total revenue declines. Okay, so in other words, we raise the price in this case, in our case, in this case, the price increased by 10% and the quantity demanded fell by 20%, leading to a loss of total revenue. So that was a warning to this company. Don't do that again. Don't raise your prices. Oh, you're right. Thank you for catching that. I made a dumb mistake here. It is 20 million. Yes, absolutely. Thank you for noticing that. Perfect. It is, otherwise it would have been ridiculous. No, it went from 20 million down to 17,600,000. That's exactly correct. And this is because we raised the price. That's what we get. People are upset. They don't want to buy more computers. In fact, they want to buy a lot less because it's a lot of money and they're going to think twice. Maybe they'll buy something cheaper. Maybe they'll just not buy a new computer this year. But this is going to be a problem. Now, having said that, though, and we didn't use this example, but it cuts both ways. What do I mean? What do I mean by that? With a high price elasticity of demand, lowering the price increases the quantity demanded by more than the price reduction in percentage terms. As a result, total revenue increases. So in other words, what the computer company should have done is actually put the computers on sale, because with that kind of elasticity, if they cut the price by 10%, they might have sold 20% more computers. Does that make sense to everyone? So when the elasticity is high, that's when you cut the price, and that increases your revenues. So they made a mistake by raising the price. Now, of course, with Starbucks, we saw the opposite. With Starbucks, with coffee, the coffee, they started out at $2, raised it to $2.20, and the result was 1 million units were sold at $2. And then when we raised the price, it dropped very slightly to 9,900,000. So these, let's see, this is 2 times 1 million. And we did already do this calculation, but let's bring it all together. And down here, 9,900,000. And that turned out, oops. Yeah. And that turned out to be, let me get out my calculator again, 9.9 million times 2.2 is, I did it again. It's 990,000. I got too many zeros in there. There we go. Much better. All right, we're good. 990,000 times 2.2 is 2,178,000. There we go. So what happened here? So with a low price elasticity of demand, raising the price leads to a smaller reduction in the quantity demanded, and again, in percentage terms, so that total revenues increase. But lowering the price would lead to a smaller increase in quantity demanded in percentage terms, so that total revenues decrease. So in other words, Starbucks would have made a terrible mistake by putting the coffee on sale. With such a low price elasticity of demand, for them, it made sense to raise the price. All right, so I just want to do one more thing. How about a quick little table? Oh, I don't like that one. Okay, and yeah, I know we're running desperately short on time, but I want to squeeze this in. And then, now this was a lot, and I mean a lot of content. When we come back on Thursday, we obviously have to go through this one more time. I mean, really, this is so much material, but I think we did well, but I think we really could stand to go through it one more time. So with a high elasticity, the price increase lowers total revenues, whereas a price decrease increases total revenues. Whereas down here, everything works in reverse. I might as well be consistent. I'll change this to decreases. There you go. All right, perfect. So the cases that we saw here today were the computers had a high elasticity of demand, and they made the mistake of increasing the price, which decreased their total revenues. The Starbucks had the low price elasticity of demand, and they were wise enough to increase their price because they knew that would raise their revenues. Lowering the price would have been a mistake. Okay? So, all right, anyway, so yeah, that was a lot. We'll get back to this next time. We'll go through it one more time. We'll get some more practice with it. But even though it seems kind of scary, I think you'll agree that it is kind of, it's very logical to say the least. So we'll go through this again, and we'll take it from there. All right. So I hope this wasn't too overwhelming today. But again, we will definitely review this and go through it all one more time. And so I will see you next time. All right. You're welcome. And maybe we'll find cool videos for this.
Thank you.
All right. See you later.